Okay. Okay, as usual, please inform me if my audio or visual are not clear. And then if you have any question, you can ask at any time. Just turn on your mic and ask your question. If you don't have any question, please switch off your mic. Uh, and then for attendance record, your attendance will be recorded automatically by team. I will base on the log in, log out. When you log in and you log out, team will record that time, and then I will refer to that time to record your attendance. And then for video recording, I will upload the video from team, and then I will share with you the link of the record of the video, and then you can find the video, the link in UKM folio under section online lecture. Please please log in into the UKM folio, and then in UKM folio you will find all the recording for our online class. Okay, for today I will continue on topic concept of continuity. Okay, in bahasa Melayu, continuity we call it as keselanjaran. Keselanjaran, konsep keselanjaran. Concept of continuity. Okay, basically, when we're talking about continuity, whether in mathematics or statistics, that refer to the in mathematics, continuity means that a function behave smoothly without any break or jump or hole in its graph. Okay, a graph is a continuous. We said the graph is continuous if the graph is not broken at a certain point. In other words, we can say that the graph can be drawn without lifting the pen, or in other words, there is no gap or jump or no break in the graph. That we call it as a continuous or continuity. So in bahasa Melayu, we call it continuity, also refer to the tidak terputus. Raja tidak terputus. There is no break, no gap. No gap for the line for the function at the certain point. That's why when we're talking about keselanjaran, normally we will refer to the certain point, certain value of x. Okay, for example, let's say if you refer to figure 5.3, okay, let's say there is only I just draw a random line here. And this graph will be used to explain the concept of continuity. Let's say we focus on 5 points here, 4 points, x1, x2, x3, and x4. Okay, you can find this figure on page 15. Please refer to page 15. Okay, at point, sorry. Based on figure 5.3, 5.2, figure 5.3, this function is continuous at the following point. Okay, this function is continuous. Tidak fungsi ini adalah terputus. This function is discontinuous. Sorry, this function is discontinuous at the following point. The first one is at point x1. As you can see, at point x1, we had what we call the white. We have a white dot here, the hollow dot or white dot here. Okay. In this case, the reason why the function is not continuous at this point, because the function is undefined at that point. When x equal to 1, the function is not defined or cannot be. There's no value for y. The value of y does not exist when x equal x1. So at x1, the function is discontinuous or tidak selanjar ataupun terputus. So in other words, we can say that x1 is not the domain of fx or of that function. Okay, that's the first reason why the function is discontinuous. So at point x2, the function is discontinuous because f the value of the function is not equal to the limit when x approach x2. When x equal x2, there is the value of x2. The value of the function exists. We can calculate the value. X2 is domain, but the value of the value of the function at that point, when x equal x2, is not equal to the limit when x approach 2. As we can see here, when x approach x2 from the left, from the right or from the left, we can see the value of y will approach this point. But the value when x equal x2, the value of the function is defined at the black point here. So in this case, there is a two value here. One value there is the value for x for the function is not equal to the limit. So in this case, we can conclude that the function is not continuous or discontinuous when x equal x2. That the reason number two why the function is discontinuous. The third one is at point x3. You can see here there is clearly show that the function is there is a break in the function at point x3. Same as at point x2, x1, and x2, there is a break. But at point x2, we can clearly see that the function is there is a gap when x equal to, for the function when x equal x3. As you can see here, the reason why the function is discontinuous at this point, because there is no limit. Right hand limit is not equal to the left hand limit. The limit does not exist. And then the value of the function still exists, but the limit does not. The limit does not exist. So that is also the reason why the function is not discontinuous. And then at point x4, the function is also discontinuous because the limit does not exist. The left hand limit is infinity. The right hand limit is also infinity. So as if you refer to the previous section, when the limit is infinity, whether infinity or negative infinity, we can conclude that the function has no limit or the limit does not exist. When the limit does not exist at a certain point, so we can conclude that the function is not continuous or discontinuous at that point. So there is four reasons why the function is tidak selanjar, terputus, or discontinuous, or there is a gap, there is a jump for the graph at point x1, x2, x3, and x4. Okay, that's why there is at least four reasons we need to know why the function is not discontinuous. So in conclusion, we can say that there is the condition, there are three conditions where the function is continuous. As you can see on page 15, the function is continuous at point x equal a. Remember, when we're talking about continuous, we normally we refer to the certain point. We just conclude at the one point. So for example, at point x equal a function is continuous at x equal a if and only if the following three conditions are met. Okay, the first one, the value of the function must be defined at point x equal a. That's the rule number one. In other words, a is the domain of x. The function is defined at point x equal a. If the function is not defined at this point, automatically we can conclude the function is not continuous. That's the rule number one. At that point, the function must be defined. There is the value of y exists. There is a black point here. Black dot point when x equal a. The second one, the limit of the function exists at point x equal x equal a. I.e., in other words, we can say that the right hand limit equal to the left hand limit. The limit of the function when x approach a must be exist. That's the rule number 2. The rule number 3 is fa. What does it mean? Fa equal to the limit of the function when x approach a. In other words, the value that you find in first rule must be equal to the second rule. The value of the function must equal to the limit when x approach when x equal a. When x equal a, there is the value of fx. The value of y, the value of fx must equal to the value of the limit of the function when x approach a. So, in other words, this three conditions must be met only and only if the following three conditions are met. If one of the conditions are not met, or in other words, the value of the function does not exist, or the limit does not exist, or the value of the function does not equal to the limit, the conclusion is the function is not continuous or discontinuous. Okay, that's about the continuity. If any orderable condition cannot be made at the point x equal a, then we have to conclude that the function is not continuous or discontinuous at that point. At point x equal a. So there is a property of continuity. I will not go explain the properties in detail. But I will proceed to the section, the last section for this topic, method to determine the continuity of the function. I will show you the example, how to find how to determine whether the function is continuous or not continuous at a certain point. But for section 5.8, there is a property I will leave to you. I hope you can review that section for yourself. Okay, for section 5.9, there's a general form for the polynomial function. As you in topic 1, we learn about the what we call it linear function, log function, quadratic, and exponent. Linear, quadratic, log, and exponent. All the function is known as the polynomial function. That function, linear, quadratic, exponential, and log, are continuous at any given point. For all these linear function, y equal to mx plus c, y equal to ax squared plus bx plus c, y equal to log bx, and the last one exponent, y equal to b to the power of x. All these functions are known as a polynomial function. These functions are continuous at any given point. In a normal condition, in a general condition, in a general form, this function is continue at any point. In other words, for linear, for quadratic, log, exponent, there is no gap. When you draw the graph, make sure there is no gap for the function. But for ratio function, fx divided by gx is continuous at every point also, provided the denominator gx must not equal 0. If the denominator is 0, the function is not defined at that point. In other words, the function is also discontinuous or to putus at that point. So in other words, the rational function is discontinuous point where the denominator equals 0, but remain continuous at all other points. I will show you in an example how to determine this point. There is one point here for rational function when the pembawa or denominator is equal 0. For example, let's say for this point. Okay, I will refer to this point. Please refer to example 5.28. Example 5.28. Okay. just for to prove that the rational function is continuous at any other point given that the denominator is not equal to 0. For example, let's say we have this function fx equal to x to the power of 3 minus 3. There is there's a cubic function, one of the polynomial function, divided by the quadratic function x2 plus 2x minus 8. Okay, this we call it as a rational function. Rational fungsi nisbah. Okay, the numerator is cubic. The denominator is quadratic. Okay, as I said here earlier, all the polynomial functions, including the cubic and quadratic, are continuous at any given point. But for this rational function, okay, this fx is a rational function. This rational function is also continuous. Selanjar pada semua titik. There is no gap for the function unless at one point where this quadratic equals 0. Okay, this one, this denominator x squared plus 2x minus 8 equal 0. Okay, we can find this number, this value. What is the value of x? So when we substitute x in the question, the answer is 0. You can use your calculator or use the quadratic formula. I hope you still remember the quadratic formula. Please refer to chapter 1. You can the answer is at point x equal -4 and +2. At this point, the fx does the f2 f -4 is equal to f2 is undefined. Why? At this point, the denominator equals 0. So any number divided by 0, the answer is undefined. So there is one example here. When the denominator is equal 0, the function is undefined. So when the function is undefined, so we can conclude that when x equal -4 or 2, the function fx is discontinuous. It's not continuous. Or tidak selanjar. Terputus. There is a gap. Tidak selanjar. There is a gap or there is a jump for the function when x equal -4 and positive 2. Okay, that's example, one of the example how to why the rational function is normally a combination of the polynomial. But there is one point here. The function is not continuous or discontinuous, or in other words, there is a jump or gap for the function, especially when the denominator equals 0. For this case, the example is when x equal -2 and -4 and positive 2. Okay, that's one of the example. Okay, the next one, how to find the continuity. Please refer to page 18. Method to determine the continuity of function, section 5.10. Okay, section 5.10. Okay, please refer to the section 5.10. There's a few examples here to find whether the function is continuous or not continuous. Okay. So example, find the point of discontinuity. Example 2. Okay, A, B. Example 5.3. Okay, you can please refer to section 5.10, 5.10, example. Example 5.29e. That's the question. Given this function, fx equal to 4x squared plus 3x plus 2. Determine whether the function are continuous at the specific point. We need to determine x equal 5. Let's say x equal 5. Whether at this point the function is continuous or not continuous, whether there is a gap when x equals 5, whether there is a jump for the function when x equals 5. Okay, there's a quadratic function. I hope you still remember there's a quadratic function. A equal 4, b equal 3, c equal 2. I explain more about I explain more detail about this function in topic topic 1. I hope you still remember this function. There's a properties, there's a theory for this function. Okay, but now we would like to determine whether there is a gap in the function when x equals 5. Okay, for quadratic function is one of the polynomial function. For polynomial function, there is no gap basically. There is no jump. The polynomial function, including this quadratic, must be continuous at any point. Okay, now we need to prove. We can prove that statement by choosing the x equal 5. Based on the theory, we know the answer is this function is continuous at that point. So how to prove that? So in order to the function are continuous, this function are continuous at point x equal 5. There is 3 condition must be met by this function. The first one, the first rule is f5 must be exist. Oh, not exist. f5 must be defined. Is defined. What does it mean? We can find the value of fx when x equal 5. So when x equal 5, so what is the value of fx? f5 equal to 4 times 5 to the power of 2 plus 3 times 5 plus 2. So based on this calculation, we know that the answer is 117. When x equal 5, y equal 117. So x equal 117. So the function is defined. So the rule number 1 is okay. It's met by the rule. The function meet the rule number 1. Okay, the second rule number 2. We need to find the limit of fx when x approach 5. In order to based on the rule, based on rule number 2, the limit must be exist. It must be exist. That's rule number 2. So we need to check. In order for the limit what does it mean by the limit that exist? The limit for the function is exist. The right hand limit when x approach 5 equal for the right equal to the limit the left hand limit when x approach 5 for the left. So in other words, we need to check whether the limit is exist. So how to check the limit of the function? We need to find the right hand limit and left hand limit for this function. So based on the previous part, okay, in order to find the limit, we have a properties of limit. So the first step, we just replace the value of x into the function. If you want to find the limit. So the first one is the left hand limit. The limit of the function when x approach 5 from the left, we just replace x equal 5 into the function. The function is 4x squared plus 3x plus 2. The answer is 4 times 5 to the power of 2 plus 3 times 5 plus 2. The answer is 117. So the left hand limit exists. There is a limit for the function. When x approach 5 from the left, the function, the y approach 117. There is a limit. The limit exists when x come from the left. The left hand limit exists. Now the left, what? Okay, how about the right hand limit? When x approach 5 from the right. For the function, the same function for x squared plus 3x plus 2. So what we need to do is just if we refer to the property of limit, in order to find the limit, we can just replace. The first step is we just replace the value of x into the equation, and then we check whether there is a limit. If we can find the limit, so that is the answer. If not, we need to choose any 2 or 3 numbers to determine the actual limit. Okay, based on this rule, we just substitute x equal 5 in the equation. 4x5 squared plus 3 and 5 plus 2, the answer is still 115. So the left hand limit, the right hand limit is 117. Sorry, the left hand limit is also 117. So in this case, we can conclude that the left hand limit, the left hand limit x approach 5 on the left equal to the right hand limit x approach 5 for the left. That is, the limit is 117. So we can conclude here, therefore, the limit of the function when x approach 5 for fx is equal to 117 exists. So the rule number 2 is okay. It's fulfilled by the function. So the next one, we need to identify these two numbers, f5 117, and also the limit of the function when x approach 5 for fx also equal to 117. So based on the rule number 3, the value of the function must be exist, and that the value of the function must equal to the limit. The value of the function exists, the limit also exists, and the both value must be equal. In this case, we can conclude that the value of fi, the value of the function when x equal 5, equal to the value of the limit when x approach 5 for the fx. The answer is 117. So based on this conclusion, based on the finding, we can conclude that since the function meet the rule number 1, number 2, and the rule of the continuity is fulfilled by the function by the fx. So we can conclude here that the fx is continuous at x equal 5. We can write here fx is continuous at x equal 5. Okay, that's how to find the limit. Okay, for your homework, okay, that for your just for you to check your understanding, your homework. Okay, now you find the limit, determine whether the function is continuous or not continuous at point x equal -5. At point x equal to -5. The answer is the function must be continuous. So you just need to prove the left hand limit equal to the right hand limit, and also equal to the value of the function when x equal -5. Okay, that is for your homework. Okay. The next one is about the example 5.2, example 5.29c. Okay. 5.29c. Okay, we have this function fx equal to 16 divided by x squared if x greater than equal or greater than 2. The function now become to the linear tx minus 1 if x less than 2. Okay, that we call it as the succession function. The shape of the function change before 2 and after 2. If the value of x, if the domain is greater than 2, the domain is greater than 2, the function is 16 divided by x squared. But when x less than 2, when x less than 2, the function become to change to the linear, become that is equal to tx minus 1. But now I would like to determine whether the function is continuous at point x equal a. I want to check whether there is a gap since the function is changed from the linear to the non-linear before and after x equal to. Now I would like to check whether the function is continuous or not continuous at this point when x equal to. Okay, so the first rule, we need to find f2. What is f2? Okay, there is two functions here. When x equal to, the valid function is this one, 16 divided by x squared. So the value of y is 16 by 2 to the power of 2 squared. 16 divided by 4, the answer is 4. So the function can be defined when x equal 4. Okay, rule number 2. We need to find the limit, the height or limit of the function when x approach 2. When x approach 2, so in this case, there is two limits should be defined. The first one, we need to find the limit of the function when x approach 2 from the left. We need to find the left-hand limit. Then we need to check whether the left-hand limit equal or not equal to the right-hand limit. So for the left-hand limit, when x approach 2 from the left, what does it mean? When x approach 2 from the value of x less than 2 but close to. So when x less than 2, okay, when x less than 2, you can see here, okay, the function become the linear function, this one. When x less than 2. When x less than 2, the function is fx equal to tx minus 1. So the limit equal to tx minus 1. Tx minus 1. So the answer is 3 times 2 minus 1 based on the properties of limit. So the answer is 5. So the left-hand limit exists. The value of the function when x approach 2 from the left is positive 5. In other words, the limit exists when x approach 2 from the left. And then the next one, we need to find the right-hand limit. The limit of the function when x approach 2 from the right. What does it mean? The value of the function, the limit of the function when x approach 2 from the right means that we choose any number close to 2 but greater than 2. Choose any number greater than 2 but close to. So in other words, we need to choose any value of x. The value of x is greater than 2. When x is greater than 2, the value function is 60 divided by x squared. So the valid function is 16 divided by x squared. This is equal to 16 divided by 4 divided by 2 squared. The answer is 4. So again, the right hand limit exists, but the value of right hand limit is not equal to the left hand limit. So in this case, we can conclude, find our finding here is the limit for fx when x approach 2 from the left does not equal to the limit of fx when x approach 2 from the right. So in this case, we can say that we can conclude that the limit of fx when x approach 2 does not exist. Does not exist. The limit does not exist. So the rule number 2 is not met by the function. So since the limit does not exist, we can conclude fx discontinuous at point x equal 2. So in other words, there is a gap. When we draw the graph, there are a gap. The graph jump at point x equal 2. That's how to determine the limit of the function. Okay, that's example how to find the limit. Okay, any questions so far?
No, doctor.
Okay, thank you. Okay, the next one, given any function, we need to find the point of discontinuity. In other words, we need to find there is no value of x given in the question. We need to determine, you need to find what is the value of x we must consider in order to determine the limit of that function. Please refer to example 5.30, 5.30a, b, and c. There is a step I share with you. There is a few steps you need to follow in order to determine the value of the limit. Okay, for example, okay, I will choose one example here. I hope you can refer to example 5.2a and also 5.3. Okay, 5.3a. Because I would like to explain the example example 5.30b. How to determine the value of the limit. Please see. Okay, this is from example 5.30b. Please refer to page 20. Okay. For page 20. Okay. Given this function fx, given this function fx, let's say we have fx equal to x plus 1 if f greater than or equal or greater than 1, the function changes to the rational function x squared minus 5 divided by x plus 3 if x less than 1. X less than 1. Okay, so we need to, the question is find refer to the find the point of discontinuity. Find the point of discontinuity. Dapatkan titik-titik yang tidak selanjar. Dapatkan titik-titik ketidakselanjaran. We need to determine the point. That's only the question. Okay, the question is very tricky. You need to know which point we must consider. Which point we must consider. Okay, there are a few tips here. The first one, we need to the point that we need to consider is the point when the function is split. When the function is changed their form. For example, okay, this function has two forms. The first one, the function is equal to x plus 1 is linear, where the x squared minus 9 divided by x plus 3 is rational. This function changed the function form change at point x equal 1, before and after 1. When x equal to 1 and above, the function is linear. But when the value of x less than 1, the function changes from linear to the rational form. So there is one point. That is the reason. There is the one point we need to consider whether the function is continuous or not, continue or not at point x equal 1. Okay, there is a one point here. The first point we need to consider when x equal 1. Why? Because at this point the functions change or split. The form of the function change from the linear to the rational function. You can find the justification on page 30. Okay, the second one, the tip is, okay, there is since this function as the rational function. Okay, we need to find whether there is the what value of x that will what is the value of x, what is f if this denominator equals 0. We need to find what is x. Okay, for example, we have x plus 3 equals 0. Is there any value for x? So we know that x equals negative 3. So in other words, when x equals negative 3, the denominator of the function is 0. This is important because when the denominator of the rational function is 0, the value of the function does not exist. When the value of the function does not exist, we can automatically conclude that the function is not continuous at that function. So for this function, there are another point we need to consider. There is the point when x equal negative 3. Why at x equal negative 3? When x equal negative 3, the denominator equals 0. When the denominator equals 0, the function does not exist. The function cannot be defined, and automatically the function is not continuous at that point. That's the reason we need to we can choose this there is a justification to choose point x equal 1 and x equal negative 3 to check to consider these 2 points to check whether the function is continuous or not continuous. If this function is continuous at this point, so we can conclude the function is also continuous at other point. So this function is continuous at any point, at any value of x. But now we need to check first at this 2 point. Okay, the first one is about the point x equal 1. Okay, point number 1 we need to consider, we need to check is x equal 1. Rule number 1, find f1. We need to check, we need to determine whether is fx exists, whether fx is fx different or not. What is f1? When the value of x equal 1. When x equal 1, so the second question is if we consider x equal 1, if we want to find whether fx exists at point x equal 1, we need to choose the right form, the right function, the right form of the function. Since that the function has two forms, rational and linear. Now we need to find x equal 1. The function is linear at least when x equal 1. X equal 1 is include in this point. So when x equal 1, the function is x plus 1. X plus 1, the answer is 1 plus 1, the answer is 2. So we can conclude that the function is defined. When x equals 2, the function is defined. Okay, so the rule number 1 is okay, is met by the function. Now we need to check the rule number 2. The rule number 2. Okay. Okay, for the rule number 2. We need to find the limit, the limit of the function. The limit of fx when x approach 1. So as usual, we need to find the left hand limit and right hand limit. The limit of the function when x approach 1 from the left. For what does it mean by from the left? We need to choose any value of x. The value of that value is less than 1, but close to 1. Maybe 0.9, 0.9999, and so on, but the value must be less than 1. So based on this function, when x less than 1, please remember, when x less than 1, okay, the function, we need to apply the rational function, the rational form of that function. The fx equal to when the value of x less than 1. The function is fx equal to x squared minus 9 divided by x plus 3. So the left hand limit equal to x squared minus 9 divided by x plus 3. So based on the rule of limit, we can substitute 1 squared minus 9 divided by 1 plus 3. The answer is negative 2. The left hand limit exists. The value is negative 2. Now we need to check the value of the right hand limit when x approach 2 from the right. What does it? Sorry, not 2, 1, still 1. Because we consider at point x equal 1. Now the limit of the function when x approach 1 from the right. When x approach 1 from the right. What does it mean? When x approach 1 from the right, meaning that we need to choose any value of x. The value of x is less than 1 but close to 1. Maybe 1.01, 1.001, 1.001. Any value of x, but the value of x must be greater than 1 and close to 1. So when x greater than 1, the function become the linear. That is the function when x greater than 1. So the right function is x plus 1. So the answer is 1 plus 1 equal 2. The right hand limit exists, but the value is 2. Okay, now you can clearly see that the left hand limit negative 2, the right hand limit is positive 2. The left hand limit is negative 2. The right hand limit is positive 2. So in other words, we can conclude here that the left-hand limit when x approach 1 from the left does not equal to the right-hand limit when x approach 1 from the right. The left-hand limit does not equal to right-hand limit. So the conclusion is the limit of the function when x approach 1 for fx does not exist. There is no limit for the function. So the rule number 2 is not fulfilled, it's not met by the fx. So since the rule number 2 is the limit does not exist, no need to check rule number 3. We can conclude here that for this case the limit does not exist. The limit of the function does not exist. We can conclude that then we can conclude here that the function is discontinuous. Fx, the limit does not. So compare the limit version for the moment because the limit equals. Okay, so fx in this case, fx is discontinuous. Discontinuous at point x equal 1. Fungsi adalah terputus. Fungsi adalah tidak selanjar pada titik x equal 1. So if you refer to the lecture note, there is a typing error here. Okay, example 3. Since the right hand limit does not equal to the left limit, the general limit does not exist. Okay, this okay. So we can conclude here. There is no need to write this. Okay, this one is not valid for this case. We just conclude at point 1 the function is continuous. Discontinuous at point x equal 1 because the limit does not exist. Okay, that the at point x equal at point x equal 1. Okay, now we need to check the second point at point x equal -3. At point x equal -3. Check whether the limit is continuous or not. Okay, now we can apply the same concept here, the same rule. The first one, we need to find f -3. And f equal to -3. The value that is the value of x is less than 1. When x equal to -3, the function is equal to this rational function. So the value of the function equal to x squared minus 9 divided by x plus 3. The answer is -3 to the power of 3 minus 9 divided by -3 plus 3. So the answer is there is a 0 divided by 0. The answer is undefined. So the first rule is not met by the function because the value of y does not exist. The value of y cannot be defined. The value of fy is f -3 is undefined. So the rule number 1 is not met by the met by the fx. So we can conclude here the function is discontinuous. Fx is not continuous at point x equal -2. No need to check rule number 2 and rule number 3 because the rule number 1 is not fulfilled by the fx because the fx is not defined at that point. So we can conclude that here that it's no need to check the limit and rule number 2 or rule number 3. At this point we can conclude immediately the function is not continuous at point x equal -3 because the function is not defined at that fx is undefined at when x equals -3. Okay, that's the case. So we can conclude here this function is not continuous. The function is discontinuous at point x equal 1 and also x equal -3. There is 2 points here where the function is not continuous. Okay, that one the example uh, for example 3 point you can refer to page 20 example 3.5.30b. Okay, there is 2 points when the function is uh, not continuous. In other words, there is a gap. When we draw the graph, there is a jump, a gap, a break. There's a break in the graph at this 2 point. Okay, for your homework, okay, again for your homework, please check whether the function is continuous at x equals 0. What happened to the function? There's your homework. Please check at x equals 0 whether the function is continuous or not. Continuous. Okay, the answer is the function is continuous. Okay, so how to prove it? Prove it. Please prove. Find the proof. Check the rule number 1, rule number 2, and rule number 3. You can find that the rule number 1 is the function is continuous, and in other words, the function is all the rule is fulfilled by the fx at point x equals 0. Please prove that statement. The function is continuous at point x equals 0. Okay, that is your homework. Okay, the next one, the last one. Okay, the last one for today for this topic. I will stop at this section 5.11, and then I will continue the topic 5, topic 6, different session in our next class. Oops, sorry. Hold on here. Wait a minute. I have problem. Okay. 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 Okay, the next session is about the share screen. Okay, the last one for today, the last part of this topic is type of discontinuity. Okay, basically there is a few types here. You can see infinite discontinuity, B, finite or jump discontinuity. There are 3 primary types of discontinuity. Infinite discontinuity, in other words, ketakselanjaran tak terhingga. Jump discontinuity or finite discontinuity. The last one is about the point or removable discontinuity. Ketakselanjaran kehilangan titik. You need to know this type of discontinuity. Okay, basically the function is said to have infinite discontinuity at point x equal a when at least one side limit increase or decrease without bound toward positive or negative infinity as x approach a. In other words, one of the limit is a infinity, positive infinity or negative infinity. For example, let's say we have this point here. Okay, in English, determine. We need to determine determine whether fx equal to 1 over x is continuous at point x equals 0. Okay. When x equals 0, as you can see here, the limit of the function is approach positive infinity or negative infinity. Okay, for this case, of course, we conclude that the function is not continuous. The function is discontinuous at that point. Okay, the type of the continuous is an infinite discontinuity. Ke tak selanjaran, tak terhingga, because one of the limit has a infinite. The limit is infinite when x approach a. For this case, when x approach 0, the function has a positive infinity or negative limit. Negative infinity. The limit is positive infinity or negative infinity. Because of that, we can conclude that the function is discontinuous at that point, and then the function is has an infinite discontinuity. So the type of the discontinuity here is infinite. Ke tak selanjaran, tak terhingga. That's the what we call it, type number 1, infinite discontinuity. The second one is finite or jump discontinuity. Ke tak selanjaran finite ataupun ke tak selanjaran terhingga. A function, what does it mean? A function has a finite or jump discontinuity at x equal a when both the right hand limit and the left hand limit exist, but their value are not equal. Okay, in other words, in this case, the limit does not exist because the right hand limit does not equal to left hand limit. The left hand limit exists and the right hand limit also exists, but the value are not equal. The left hand limit does not equal to the right hand limit. So in other words, the left hand limit, the limit does not exist. You can see to the example 5.30b. We discussed before this at point x equal 1. At this point, when x equal 1, we can see here the left hand limit is -2, the right hand limit is +2. The right hand limit and the left hand limit exist, but the value are not equal, so the limit does not exist. So for this case, the type of discontinuity is jump discontinuity for at point x equal 1. That means by the jump discontinuity. So the jump discontinuity refer to the limit. The left hand limit does not equal to the left hand limit does not equal to the right hand limit. Okay, the third one is about the point discontinuity. Point of removable discontinuity. Ketak selanjaran kehilangan titik in bahasa Melayu. So the function is called have a point discontinuity at point x equal a when the general limit exists. The general limit exists, but the actual function value, the value is undefined at that point. The limit exists, but the function is undefined. As you can see in example 5.30b. In example 5.30b. At point x equal -3. For this case, the function does not exist when x equal -3, but the limit exists. If you find the limit, the function is undefined, but the limit exists. The limit of the function when x approach 3, whether from the left or right, the value of the limit is equal to 0. But so in other words, the limit is exists when x approach when x approach when x approach -3, but the value is the function is undefined. That's all. That's all. The function is undefined. Since the limit exists, but the function is undefined, we call it the function. At this point, the function is discontinuous. When x equal -3, the type for the type of discontinuous is the sorry, it's a point or removable discontinuity, removable discontinuity, or ketakselanjaran kehilangan titik. So in other words, there is a three type of discontinuity. This infinite discontinuity, and then finite or jump discontinuity, and the last one is about the point discontinuity or removable discontinuity, based on the condition whether this type is different whether the function is exists, or by whether the limit exists or does not exist. Okay, that's about the type of discontinuity. Okay, I think okay, that's all for topic 5. In other words, we have finished. I have finished explain about the topic 5. Topic 5 is again about the limit and continuity. Okay, the next topic is topic 6. Is also there is another topic. The other topics. The topic is about the differentiation, but I will explain that topic in our next class. I will not explain today. I will stop here for today for today class. Any question before I end this meeting? And then please remember, next week we have exam. We have a ujian, a test, mid test for set 7, F6 and 7 during our class. And then in DK4 or DK3, subject to your set. Okay, the further information about the test, I will share with you time by time. And then I will share with you time by time, of course, in our WhatsApp group. If you have any question related to our test, you can WhatsApp me at any time. But for today, I hope you will prepare for our test for the first for 6 for set 7. The test is on Wednesday, and for set 6, the test is on Thursday. Starting from 11 to 2 p.m. The detail about the structure of the question. Basically, there is a two sections, section A and section B, MCQ and also structure question. Okay, the detail, the number of question, I will share later. And then the test will cover topic 1, topic 2, and topic 3 only. Okay, I hope if you want to know the type of please refer to the exercise that I upload in for you. I hope you can do all the exercise. You can review all the exercise and my lecture note as a preparation for you before your test. Okay, that's all for today. Any question?
Doctor, I have a question.
Yes.
So basically, because topic 4 is not included in this semester,
Yes.
means that this semester we will cover 5 chapters only, right?
1, 2, 3,
5, 6.
5, 6, 7. Yes,
6,
that's
7.
correct. For this semester, for this set, for my set, I have skipped topic 4, algebra mathematics, because algebra mathematics is only optional for topic 1. Basically, there is an alternative method, and then that will not affect your syllabus at all, because for final exam there is only 3 topics, 5, 6, and 7. So in total, for our set, there is only 6 topics. Yes, that's correct.
Okay.
Okay. Any other question? Any other question? Okay, if there is no question, okay, that's all for today. Thank you for your attention. Good luck for your final exam, for your not final exam, for your mid exam next week. And okay, for your attendance, please wait until I end this meeting because your attendance will be automatically recorded by Teams. And then, okay, for recording, for video recording for our class this morning, I will share the link in UKM Folio later, maybe next week. So far, I have uploaded all link for our online class. You can refer to UKM Folio. Okay, that's all for today. Assalamualaikum and good morning. Good luck for your final exam. See you next week.
Thank you, Dr. Assalamualaikum.
Waalaikumsalam warahmatullahi.
Thank you, Doctor.
Welcome. Okay, welcome.